So now we're looking at a complex division problem involving rational expressions. And simply what that amounts to is that we have a rational expression in the top of a fraction and a rational expression in the bottom of a fraction. So our first step is just go ahead and write this as your typical division problem. When we do that, we end up with 3x squared plus 7x plus 2 over 4x plus 24, and that's going to be divided by 3x squared minus 14x minus 5 over x squared plus x minus 30. And now we'll rewrite that as a multiplication problem. So our first rational expression, we keep the same, 3x squared plus 7x plus 2 over 4x plus 24. And then we will multiply by the reciprocal of our second rational expression, which is x squared plus x minus 30 over 3x squared minus 14x minus 5. So the next step is to factor completely all of the both numerators and both denominators. So with 3x squared plus 7x plus 2, will it factor? Well, let's see. We have, if it does factor, we're going to end up with two binomials. We know that 3x is going to be the leading term in one of the binomials and x in the other, because 3 is a prime number. So those are our only options. Those are our only factors. We know it's going to be plus plus because we're adding 7x and we're adding 2. So plus, plus. Now, what are the factors of 1 and 2, or of 2? It's just 1 and 2. So we know it's either going to be 3x plus 2 times x plus 1, or 3x plus 1 times x plus 2. And if you use trial and error, you will see that 3x plus 1 times x plus 2 is the factorization. With our denominator in our first rational expression, we have a common factor of 4. So we'll factor out the 4, and that leaves us with 4 times x plus 6. Now we'll move on to our second rational expression, what we're multiplying by, which again is the reciprocal of what we were originally dividing by. So x squared plus x minus 30, will that factor? So are there any two values that will multiply to negative 30 and add to 1? Well, yeah, x plus 6 and x minus 5. 6 times negative 5 is negative 30, and 6 minus 5 is 1. So there's our factorization of that numerator. And then remember what I said earlier, that chances are, now we can't just use this in general, but specifically in this section, it's a good idea to just remember that we're probably going to end up with something that's a little bit simplified when we get to the final solution. So chances are, if we have a factor in the numerator of the first rational expression being multiplied, we're going to end up with, at least one of those factors in the denominator of the second rational expression, what we're multiplying by. So we have 3x and x, because again, 3 is a prime number, so those are the only two factors. And then since it's minus minus, we know one is going to be positive and one's going to be negative. So chances are we're going to have this 3x plus 1 here. So what does that leave us with as an option for the other one? Well, to get negative 5, we'd have to have x minus 5. And that does work. 3x squared minus 15x plus x is minus 14x, and then 1 times negative 5 is negative 5. Then rewrite it all over the same division bar. We just multiply across the top, multiply across the bottom. So 3x plus 1 times x plus 2 times x plus 6 times x minus 5 all over 4 times x plus 6 times 3x plus 1 times x minus 5. And then we go through and we cancel the like factors, the common factors in the numerator and denominator. So 3x plus 1 cancels. X plus 2 is only in the numerator, so it does not. X plus 6 cancels. and then x minus 5 cancels. So that leaves us with a solution of x plus 2 over 4. And it didn't look like we were going to get that simplified of a solution when we first started, but when we factor cancel like terms, we do end up with that. I also like to note again, x can't equal -6, x can't equal -1/3, and x cannot equal 5. Because if we look at our denominator before we cancel common factors in the numerator and denominator, each one of those will make the expression have a denominator of 0, which would make us have an expression of 0 originally. Technically, we also would need to look at any of the factors that didn't cancel, that came from the original 2 denominators. So whether it would be 3x squared minus 14x minus 5, or whether it would, because that would make the denominator, our original denominator 0, or x squared plus x minus 30. So technically, we should also even be looking at those as well. In this instance, we're going to end up with the same values that we have here. The x can't equal -6, x can't equal -1/3, and x cannot equal 5.